Welcome to further mathematics class. We shall discuss sets. Lesson outline include equality of sets, subset and supersets, finite and infinite sets, universal sets and unit sets, empty sets, and cardinality of a set. Equality of sets. Two sets A and B are said to be equal if A is a subset of B and B is a subset of A. The element of set A is the same as the element in set B, and the order of arrangement of the elements in each set is not important. This means that the element in set A or the element in set B might be arranged in ascending or descending order. You can also arrange these numbers in different pattern. As far as each of the elements in the set A is the same as each of the elements in set B, then it is known as equality of sets. Alright? Example 1. State whether or not the following sets are equal. Roman figure 1. The elements in set A are A, B, C, and D, and the elements in set B are E, D, A, and C. Roman figure 2. The elements in set F are 1, 2, and 5, and the elements in set H are 5, 1, and 2. The elements in G, that is set G, are 3, 5, 6, and 7, and the elements in set E are 3, 5, and 6. Now, let's look at these three examples and observe closely. In Roman figure 2, the elements in F set F are 1, 2, and 5, and the elements in set H in that same Roman figure 2 is 5, 1, and 2. What does this mean? It means that the elements in F and H are the same. That is, they are equal. And that is what I said about equality of sets, that it might not necessarily be arranged in sequential order, either in ascending or descending order. So the elements there are what? Equal. So in Roman figure 2, F is equal to H. In Roman figure 1 and Roman figure 3 respectively, A is not equal to B and G is not equal to E. Why? Because all the elements in set A and set B are not the same, and the set G and set E are not also the same. Subsets. Consider two given sets A and B. If the set A consists some or all the elements in set B, then A is said to be a subset of B. If A consists some or all the elements in set B, then A is said to be a subset of B. Example 2. If the elements in I are 2, 4, 6, 8, and 10, and the elements in M are 4 and 10, the elements in N are 6 and 8, and lastly, the elements in Q are 2, 4, 6, 8, and 10. Now, we can now say that M is a subset of I because the elements in M are contained inside of I. So, also, N is a subset of Q because parts of the elements in N or all of its elements are present in Q, and Q is also a subset of I for that same reason. Supersets. If the set A is a subset of B and there is at least one element in set B which is not in A, then the set A is called proper set of B. B is now considered as a superset of A. For example, if A is equal to ABC and B is equal to ABCD and E, A is a subset of B and there is at least one element, that is D and E, in set B which is not in A. So we can say that set A is called a proper subset of B. Also, B is considered as a superset of A. Alright? Finite set. When the number of the elements in the set is finite, it is a finite set. Example, if set A is all positive integers greater than 1 but less than 10, the set A is called a finite set. Also note that it is called a finite set because the end of the number is defined. You are looking for all positive integers greater than 1 but less than 10. So it means you have the end of the number is defined. Alright? Positive integers greater than 1 but less than 10 starts with 2 and ends with 9. Infinite set. When the number of the elements in a set is not finite, it is called an infinite set. Example 4. If set A is equal to all positive integers, then the set A is an infinite set. It is an infinite set because the end is not defined. That is, it tends to infinity. So in this case, all positive integers are 1, 2, 3, 4, 5 till infinity. Therefore, since the end is not defined and it does not have a specific number, it is called an infinite set. Alright? Now let's consider another heading which is called empty set. When a set contains no element, it is called an empty or null set. A null set is denoted by phi or empty set notation. Example 5. A is equal to human beings with tail. The answer to this question is empty set because there is no human being with tail. B are all prime numbers divisible or divided by 5. There is no prime number that is divisible by 5. So it is called what? An empty set. C is all the months of the year that starts with the letter B. There is no month in the year that starts with the letter B. So all these three examples are empty or null sets. All right? Cardinality of a set. The number of elements in a set is called its cardinality. Considering set A is equal to A, B, C, D, and E, the number of elements in set A is 5. Therefore, its cardinality is 5. So when you are looking for cardinality of a set, you look at the numbers of the element present in that set. Alright? Let's consider this example. Determine the cardinality of each of the following sets. Set A has 5 elements in it. Set H has 3 elements in it. Why? Because 2 elements are grouped. Set G has 4 elements in it and set T has no element in it. Now the solution to that question is set A contains 6 elements. Set H contains 3 elements Set G contains 5 elements and set T has no element in it. And the following are called the cardinality of sets. Universal set. The set which contains all the possible elements under consideration is called universal set. I repeat, the set which contains all the possible elements under consideration is called the universal set. The universal set is denoted by the symbol below. Example 6. Given that x is equal to all even numbers between 1 and 20, where the first number is 2, followed by 4 and 6, and ends with 20. So each of the elements in this set are even numbers and they are 10 all together. Therefore, the universal set is 10. Unit set. A set which contains only one element is called unit set. For example, A contains one element and that element is x, which is called unit set. Also note that unit set is also called singleton set because they both contain one element in a set. Thank you for listening and see you in the next class.